Can you see my screen?
Yes. All right. Whenever you're ready,
Wait, is the rest of the team here? Wait, let me just make sure.
everyone should be accounted for.
All right, cool. Great. Awesome. So yeah, ready. So hi, my name is Yoni. I'm part of the EnerHack International team that is taking on the Sterlite Power Challenge. We have developed a solution called SOS, or Safety Optimization Software. The team consists of myself, Yoni Peleg, Mariko Ogawa, Grace Cassidy, and Tamir Peleg, all over the world, hence international. The challenge, as we understood it, was to increase behavior-based safety at electric grid construction sites by using digital technologies. And our approach to the solution was to try and optimize the supervisor's time and therefore improve the worker's safety behavior. In essence, what that means is that we want supervisors' decision regarding where to be at each moment during the day to be data-driven and not done just based on intuition. The supervisor can't be at each site at once, so optimizing where to be based on data can increase the efficiency and minimize safety risks. Our solution is based on three main stages. The first is data collection, then analysis, and lastly, resource optimization, where the resource is the manager's time at the site. We'll have cameras at each site that can follow the work that's being done, and then an algorithm can deduce which site is at a higher risk and decide where the supervisor should be based on the highest safety priority. The data that we'll be collecting will come from three main sources. The first is reports that will be manually inputted into our system, and we'll gather data about each employee. Now, this can be useful because supervisors, useful because certain employees can be a bit more problematic than other employees, or certain gangs can be more problematic than other gangs. And if we have that data, supervisors should be more attentive to those specific gangs. We'll work with open source data, such as weather, which has profound effect on safety. And lastly, we'll have a camera, one camera at each site that will, first of all, give live feed to a remote monitor that the manager will have, but will also allow to work with different technologies such as QR code and to be able to scan QR codes that we thought we could put on safety equipment, and using image processing techniques, be able to report whether certain employees are wearing safety equipment or are not, and therefore tell the supervisor if something wrong is being done. So the way our optimization software works is quite simple. We will give each hazardous parameter at a site a weight. And then using known data models such as regression or neural networks, we'll be able to determine the total hazard level at each location. Then we'll use the weighted traveling salesman problem with a time constraint to tell the supervisors where to be and when based on the total hazard level of each site. So how does that improve the safety culture? First of all, a camera at each site will immediately change the behavior of the employees. Also, the supervisor will be located at the most critical site at the most critical time. But also, we want to incorporate a reporting system mechanism that will use real-time image processing to determine where an accident has happened based on a physical flag that will be raised, kind of like the Andon cord at a Toyota production factory. The camera will detect the flag using image processing techniques and then report to the supervisor that something has happened at that site. We want to also incorporate an incentive program that will incentivize the workers to and give them a reward if they follow this Andon protocol. And therefore, workers will be motivated to self-report. Remember, if the more data, more reporting that we have, the easier it will be for us to prevent this from happening using our data and analysis techniques. And of course, on the other side, penalize workers who have a repeated offense of not reporting. Again, remember, everything is captured on camera. So the cost analysis of this solution is divided into two basic parts. The first is the more physical attributes of the solution, which include a camera, power storage, tablets. All of these are.
That's time. Please wrap up any last thoughts. Thank you.
Okay, so that's the cost analysis. And lastly, to sum up, we believe that the solution will both reduce the amount of workspace hazards and will promote responsible employee behavior. Thank you.
Great. Thank you very much. And let's have 5 minutes for Q&A.
So in terms of your algorithm to identify where the supervisor should be, what kind of options you looked at? What are all the variables, input variables that go into it? Is it only the hazard of the location, or based on the work that is happening, or any other parameters? And how do you feed this data into the model, and who will run this model? So can you elaborate a little bit more on these aspects to make it workable, the solution?
Yes, sure. I can take it. So first of all, we want to have two levels of work for the algorithm. One is a daily that provides a daily schedule based on all the data we gathered, and you can see it now on the screen on the data collection. And another one is a live feed that mostly relies on the cameras and what's going on in the site, because the sites are relatively similar to each other. We talked about it in the Q&A before. You have a tower, and you can easily recognize places and activity that is going on in there. So for example, if something is going out of the schedule or happening out of the time, it can elevate the risk that this activity gains. And our approach would be get all this data to the engine, get this data weighted with the statistical analysis that we're going to perform. And then the optimization model would take this weights under the constraint of time to make sure the supervisor collects the maximum amount of weights during the day. And by that, being at the right place at the right time to maximize the resource to achieve the highest safety possible.
So one of the key aspects is this live data should get processed real time to get a perfect weight to give input to the supervisor where he should be.
Yes. So if you have the basic schedule that is more computer intensive, you can calculate the changes pretty fast, and the optimization model can update online. So you have most of the weights ready from before, and then you need to calculate only the changes. So you can do it live based on 3G, for example.
I think linked to that is that three-step flow that you had. If you could go to that slide. Yeah, this one. Is this happening at a daily level, or is the analysis done more at a backcasting level, and optimization is the one happening at a daily level?
So the analysis happens both on a more like general all the time, like a monthly, as the data is gathered, and we will have daily weights produced every day. For example, if the weather changes or if the gang changes, you need to update the weight for each site. But for example, if you talk about, let's say, working on height, so this has a certain weight, but the weight will be changed if there's wind, if there's poor lighting, if there's, I don't know, fog or if a specific gang is working in a specific location. So you need to update it daily. And then
Okay.
we can have a daily schedule for the supervisor. But if things happen during the day, which we all know can happen, it gets updated. So if he was planning to go for a specific place and in another place we recognize some sort of a hazard, for example, somebody is doing thing that is out of schedule or he wasn't supposed to do, we can update the schedule and he can go there next to make the work more flow and achieve more points.
So how much of the historical data is captured in analysis? I mean, when you start a site, you start from a clean slate. Can you put in your methodology, put in like historical data of similar companies and
so we were informed that you have some data collected from past projects on Excel sheets. So this need to be analyzed, and also we need to make it compatible to our system. But definitely we can rely on past data.
Yeah, one last question. In terms of as you were doing the hack and looking at the research reports, what kind of systems or research papers or algorithms that you found to support the structures that you are talking about in terms of integrating a BBS with a traveling salesman problem, those kind of literature? Did you come across a lot of literature or some literature, or where do you see it?
Yeah, so for the traveling salesman problem, I personally did a project in the summer solving a similar problem. So the modification would be relatively easy, just adding weights and the time constraint that the supervisor will have. So this should be fairly simple to implement. I personally have some experience with that.
Yeah, actually, my question was not on traveling salesman problem, making it better, but my question was more related to this whole scheme of, putting these things together. Is it done before? What kind of evidences that we have from the literature that this works? I mean, intuitively.
So I think we haven't found evidence for the combination of each of these, but each one individually works on its own.
Yeah. Okay. Thank you.
Great. That's all the time we have. Thank you, EnerHack International, for your presentation and your time. Have a good rest of your weekend.
Thank you.
Thank you.
Thank you.
Thank you.